Good afternoon, everybody, to all gathered here. Aspiring students, current students, engineers trying to do postdoctorate and or rather PhDs and masters. So, a very good afternoon to all of you. First of all, thank you to EnGenius and the Times of India for giving me this opportunity to speak today. It's really very heartening to be able to speak to young students and aspiring engineers like you. Now, I don't want to give you any sort of moral lectures or uh, sort of philosophical advice on what you should do with your lives. What I thought instead I would do is that I will share with you the kind of work that we are doing here and the interesting things that engineers can do to contribute to society at large. Okay, so from that perspective, it is going to be a sort of a technical talk, but in a way that will make you understand the importance of doing engineering and being engineers. So let me begin my talk today. It's titled Future Energy and Water from the Oceans. I'm Purnima Jalihal, and I'm heading the Energy and Freshwater Group in the National Institute of Ocean Technology. We are located in Chennai, and we actually come under the Ministry of Earth Sciences. Basically, people confuse us with the National Institute of Oceanography, which is in Goa and is a CSIR lab. We are a technology lab and they are science. The divide is in that manner. They do oceanography and science and we do technology, and we are largely engineers in this institute. So let me tell you briefly about the kind of things that we do here. We are the only institute in the entire country which does ocean technology. Okay, you don't have any other institute in the entire country, and we have four main core areas. One is energy and water, which I look after. Then there is deep sea technologies, where we are trying to develop remotely operable vehicles, and we are trying to do mining in deep waters, and we are also trying to make the first ever manned submersible for the country. That means a human being will go down to a depth of 6,000 meters, and he will be launched from a vessel, and he will be able to go and look around and come back. This will be the first time ever anybody has done in the country. Just like ISRO sends satellites, we will be sending this human sphere below water. We also have a group which does coastal engineering. We look at how the shores are getting affected, environmental impact assessment, and things like that. And we also have other groups which look after ocean electronics and acoustics and things like that. Basically, all technologies which are required for sustainable development of the oceans. We believe in being environmentally friendly, and we all these are multidisciplinary engineering activities. We have our own ships which we use to do all these activities, and we also have a network of data boys around the country. You must have heard of IMD, all of you, the meteorology department, which predicts the rain and the tsunamis. Well, NIOT plays a very big role in that. We have the data boys. These send the data to our sister institute in Hyderabad, from where the modeling is done, and finally the prediction is done by IMD. So NIOT plays quite a big role in the atmosphere and weather predictions of the country. So having said that, this is all the NIOT activities at a glance. Now let me show you some basic information about energy and water. Now all of you know we are a hugely populated country. Even as young students, you would be aware of how difficult it is with the power crisis and the water stress in the country. If you look at the India's energy breakup, we have the total, within the total breakup, the coal is what is the maximum percentage that you see as the type of power. Okay, it is followed by various other things, and then if you see the renewable energies, which is looked after by the Ministry of New and Renewable Energies, it's like really quite low. So we see there's an excessive dependence on coal. And why do we have the need for renewable energy? Okay, so coal is, fine. So first of all, uh, you know very well that coal is a fossil fuel. Okay, fossil fuels are depleting. Now there are lots of remote areas in India which still do not have access to power. Several Indians still use traditional fuels like firewood and biomass. Now, all the emissions which come from such fossil fuels, 40% of them consist of carbon dioxide. And as you know, this is really leading to climate change. Now, in all this scenario, there is therefore the need for renewable and clean energy. And all of you have heard of solar and wind energies, right? But I'm sure many of you haven't heard of ocean energy. In this scenario where solar and wind is already being done in the country, we need ocean energy, and I will come to that shortly. Now we come to water. Okay, so this is the picture of the earth. Now it's made up of 71% of water, and the fresh water is only about 2 to 2.5%. Okay, so what does this mean? Is the water enough for everybody in the world? Now, India, as you know, is one of the most water-stressed countries in the world. Now, these are not just pictures. These are actual pictures taken last year in Chennai when there was a very, very severe water crisis. The bottom picture is a picture from Rajasthan. And, these are scenes that we have got used to seeing. People gathering near the tankers, desperately trying to fill pots. So we know we are one of the most water-stressed countries in the world. And the primary reasons for this water stress are the unavailability of fresh water or the water scarcity per capita. Okay. Now, there are various reasons. There is over exploitation of groundwater. There is a severe pollution of rivers and lakes. And of course, there are other things like management and water distribution networks. Those are, there are some issues with those as well. And also climate change also causes an additional water stress. I don't want to go into the details of all these, but this is to give you a flavor of why energy and water are important today. Okay, so now how to mitigate this water stress? Broadly, we classify it into three different sort of areas. One is conservation, one is augmentation, and one is management, right? So conservation is what we should all do at our homes. We should do rainwater harvesting. These are basic things that we all mandatorily should do today in India. Then, of course, is the management, which is led to the water boards and the municipalities and the governing bodies. So we will not talk about that. Now, where do engineers come in then? Engineers come in augmentation. Okay, so there are some questions which I will touch upon as we go along. I can see some of them in the comments. I will touch them as I go along. So just bear with me. Now, augmentation is where engineers can come in, right? So how do we augment? The basic thing that one could do is treat wastewater and use that for domestic purposes. This can really save water. If you take water from the kitchens, treat it, and then use it for your flush, it really helps in saving water. A lot of industries in India, about 15% of the industries in India are throwing out waste which is not even treated. This, if it is treated, will lead to additional water. Now, the third and important method of augmentation, and which I will be speaking of today, is called desalination. I don't know how many of you have heard about desalination, but you will hear from me now. So this is again where engineers play a very, very important role. Now let's look at the Indian scenario. Okay, the Indian Ocean is the third largest water body in the world. This covers about 20% of the Earth's surface. Now, the Indian geographic area is also very large, as you know. It's about nearly 3.3 million square kilometers. But more interestingly, if you can see in the picture, there is a green hashed area which I have shown. So this is called the exclusive economic zone. Now, each country which has got a coastline has some area allotted to it by the international rules, and this is called the EEZ, or the Exclusive Economic Zone. Now, India has got a huge coastline. It's, 7,500 to 8,000 kilometers. Basically, we also have the Lakshadweep Islands in the Arabian Sea, and the Andaman and Nicobar Islands in the Bay of Bengal. Because of this, the EEZ is very large. You see, the green shaded area is very large for India. And about 30% of the population lives along the coast, and those areas are extremely water stressed. Now, this is the reason why desalination takes a very, very important role in for India. Yes, somebody said just now that Israel does desalination. You are very correct. Saudi Arabia does a lot of desalination. It has got the maximum number of desalination plants in the world, and so does and Israel also has several. But there are differences in the technologies that they use, and what I will be showing you today. Okay, so there are actually, they are based on three different kind of what shall I say, methods. One is distillation, and that is like, it consists of 3 or 4 different methods: multi-stage flash, multi-effect distillation, and the thermal mechanical vapor compression, etc. So the reverse osmosis and electrodialysis are what we call membrane type of methods, and hybrid systems are also there which combine both. Now, membrane system, see, RO, many of you must be having small home RO systems for drinking water. You also have huge RO systems where they treat brackish water and seawater, and there are a lot of issues with membrane systems actually. First of all, a lot of brine is generated, because when you remove in the osmosis system, when you hold back the salts and generate only fresh water out of the membranes, then what gets left behind is a thick salt concentrate. Okay, so this is very, very detrimental if you put it back in the ocean for the live fish and the ecology. Also, the membranes, have to be replaced every so often, because as and when you keep passing day in and day out the salt water through it, over a period of time they get clogged and then need to be changed. So they, in general, though for brackish water RO is the only way in hinterland in small capacities, seawater RO still needs a lot of improvement, because you have to do reject management. It is ecologically unsafe. It needs very skilled manpower. It also needs imported membranes. Seawater membranes are still imported in India. So now I'll show you. I basically want to use this forum which EnGenius has provided me to show you some of the really exciting and challenging works that are not only can be done, that are being done today in India right under your noses, and you're probably not aware of it. And these are like extremely high challenging engineering works, and you need to probably you'll find more excited about you'll feel more excited about engineering and technology development once you see this. At least that's what I hope to do today. So let's talk about NIOT's low temperature thermal desalination technology. Okay, now many of you may not be aware that as you go from the surface of the sea to the deep sea, the water becomes colder and colder. Okay, so this is what we call the ocean temperature profile. This generally comes in, you can see it in any oceanography book. These are the, this is the temperature that you find in the oceans in general. Now, being a tropical country, you see the top is being shown somewhere between 28 and 30 degrees Celsius. This is generally what the temperature we have in India all through the year. And as you go down, the temperature doesn't change too much. Okay, so these are, this is a feature which is... It's come back, it's come back. So I'm sorry, there was a break. I think some network glitch. Sorry about that, but we are back here again. So I'd like to talk to you about, I just talked to you about the temperature profile, and now I'll talk to you about the Lakshadweep Islands. So there's a set of islands in the Arabian Sea called the Lakshadweep group of islands. About 10 or 11 of them are populated. Okay. And you see the colored picture at the top corner. It is basically got a lot of colors. It's a color map, and these are like what are called atolls in the sea. They are like mountains in the sea. Okay. So just the top little bit is actually available as land, and the rest of it all is underwater. So the bottom picture shows what it looks on top, and it's basically a mountain in the sea. So you have the deep water very close to the uh, to the shore or the beach. Okay. Now these are very small. Now the island I'm going to talk about is Kavaratti. It's just about barely 7 kilometers long. Many of us, I mean, I travel more than 7 kilometers each day to office. Okay, so very small, and the largest width is about 3 kilometers. So why did we think of doing desalination at Kavaratti? Okay, the population is just around 10,000 people, and the water requirement was met partially by rainwater and groundwater storage, which lasted for about 6 to 8 months only. It's a very small area, so rainwater harvesting is also, you can only do so much. Now it's these atolls are basically made of calcium, and they're calcite based. Okay, so the groundwater, the pH is very, very high. The groundwater is highly polluted because they're discharging the sewage right there next to their homes. So the groundwater gets highly polluted, and it's also very hard. The TDS is a minimum of 1000 to 3000 ppm, which is unsuitable for drinking. TDS means the total dissolved solids in the water, and this by drinking water norms has to be less than 500. Okay, so now why did we try to do that in Kavaratti? Why the earlier attempts failed? So first they had tried reverse osmosis or RO, and these plants failed because these islands are really cut off from the mainland in the monsoons. The ships don't ply during those times, and transporting the chemicals needed for the pre and post processing of RO systems was not possible during the monsoons. And the brine formation was a threat to the environmental to the pristine environment of the islands, because they are made of coral, and it was really detrimental to the surrounding flora and fauna, and it needed skilled manpower. These islands have very, very low educational levels, so it was very difficult to find people to run these plants. In this scenario, therefore, we decided to do the first ever thermal desalination project in Kavaratti. It was more like a demonstration that we decided to do. We really took the big risk of trying to do this for the first time in the world. Now, what does this involve? It's a very, very simple principle. One is that you know that very well that when you're boiling water on the gas, it just boils at normal pressure, right? It's at atmospheric pressure and it boils. But this temperature of boiling is 100 degrees Celsius. Now, suppose you were to put this water in a container and bring the pressure down to something like 28 millibar, right? That is below atmospheric pressure. Then it will start boiling at 28 degrees itself. So as you lower the pressure from 25 to 20, from between 25 to 28 millibar, it even starts boiling at 28 degrees Celsius. So this is all that we have done. As a physics principle, it is very easy to understand, and this is what we have done. So as engineers, you should be able to visualize this. You have a vessel which is enclosed, kept under vacuum, and then you pass water through it, and it starts boiling at 28 degrees Celsius. So what does 28 degrees, why is it significant? I just now showed you a profile where the surface temperature of the sea is 28 degrees Celsius, right? So that temperature, if you make it go under vacuum, it will boil. Now, the colder water at the bottom, if you bring that and use that in a what we call in engineering parlance as shell and tube condenser. If any mechanical engineers are there, in the group listening today, you will understand what a shell and tube condenser is. So if you bring cold water and pass it through a condenser, this 28-degree water which has boiled and become vapor will become fresh water. And that is what this picture depicts. Okay. So this is finally what we did in Kavaratti. This is the layout of the plant. Now you have the plant on the land. Okay. You see a two double-lined sort of object which is going from the shallow water to the bottom of the water, right? That is called the cold water pipe. That is what is pumping the cold water from the depth of about 300 meters, and it is bringing it to the surface. Now the yellowish portion, that is the sump where the pumps are located, and the cold water pump continuously pumps cold water and transmits it to the condenser on the land. Now this is the first of its kind. This was done in 2005, 15 years ago. It is totally indigenous. Okay, nothing is imported in this plant, and it has not seen any environmental impact even today. Okay, now in the Oki cyclone, everything was, nothing happened to the plant, especially the cold water pipe. Now the cold water pipe is the biggest challenge that one can actually do a design for. So this is a multidisciplinary project actually. It has civil, which is obvious. You need the bridge and the plant platform. The cold water pipe, you need to have ideas and understanding of structural dynamics and the loads in the offshore. It's definitely a mechanical oriented project because of the process components. It has a lot of electrical because what we do is we have to keep measuring the pressures, temperatures, the vacuum levels at all times, and powering the three pumps, the cold water pump, the warm water pump, and the vacuum system. Now this power that is required, as well as the instrumentation, the entire thing comes under the electrical and instrumentation, and also the offshore, because we had to actually deploy this cold water pipe. Now, having done this first time ever in the world, what is the fallout of it and how was it done? On the left picture, you will see two black pipes. Now, this is a very special pipe. All the people who are engineers in this audience, there is a material called high density polyethylene. Okay. So these pipes, this is a kind of a polymer, a plastic, and it has a beautiful property. Its specific gravity is only 0.95. Okay. So because it's only 0.95, this material floats in water. So when this floats, this idea that it floats itself can be used to deploy this pipeline. So what we did, we made a 600-meter long pipe. We joined it together and pushed it into the water. It automatically floated. You can see in the bottom two pictures how the pipe is floating in the sea, right? So we used simple boats and a barge to take this pipe, and then we put it in the location. We held it down with a weight at the bottom and a weight at the top. Now, let me tell you, in conventional sewage treatment plants, or what they call as outfall pipes, even in the big desalination plants, they use high density polyethylene pipes and then they weight them down with cement concrete blocks, okay, so that it won't move under the action of the waves. If we had done that design for this project, we would have needed something like 900 tons of cement and concrete. Okay, the blocks would have weighed 900 tons. Instead of that, we did this thing where there's only 8 tons at the bottom and some 3 tons at the top. And even today, after 15 years, this configuration has withstood the test of time and the storms and the cyclones. It is still pumping cold water even today. So we are obviously very proud of this project. You need chemical engineers for the process. You need metallurgical engineers for the actual components, because the flash chamber and condenser, you need to worry about corrosion. So you need to know what materials to use for those. Now, there are several challenges in the ocean. All of you must have seen waves on the beach, but Oceans, the waves can be quite detrimental for design conditions. Sometimes the conditions are so severe that engineering solutions which work on land need not always work at the sea. And then there are other engineering design issues like corrosion, biofouling, and varying loads and things like that. Now, in India, still the offshore infrastructure is very limited. Expertise is limited because we are the only people doing it. So, we are the pioneers. And this completely multidisciplinary engineering project has become a tremendous success. This is what it looks like today after it was commissioned. And the best fallout of it is, for the first time, the tribal community living there got access to clean water. And the first comment that I heard when I went back there for supervision was that they never knew that the tea tasted so good. They said they didn't know how chai tastes, and they were like surprised that tea can taste so good, because first time they were making it out of very good and clean water, right? So now, what are the impacts and outcomes of the Kavaratti plant? It became the main source of drinking water, and the salt-related diseases like hypertension, kidney stones, all these things improved. The health of the islanders improved, and then the local islanders have begun to run this plant, and it sort of generated a lot of interest, because when they run it, they feel it's so important. For NIOT and for India, this is the first ever plant in the world, and we developed a lot of expertise in the complex civil construction, mechanical engineering, offshore engineering, electrical, electronics, instrumentation, and metallurgy. We have developed a whole lot of expertise in all these areas, and it's a completely in-house and indigenous work. And obviously, we are very proud of it, and the rest internationally now this has become very well known. So we have now implemented it in 2 more islands, and after that now 6 more are underway in Lakshadweep. Subsequently, to scale up, we demonstrated it on a barge mounted uh, on a barge for 1 million liters per day offshore of Chennai. And we also, there's another interesting thing that can be done. Somebody is asking a question of can such a plant be developed for a city like Mumbai? Now, it can be done if, first of all, in the mainland, you don't have deep water close by, so you will need an offshore barge mounted plant like the one shown at the bottom in the center. But there is something else you can do. The same technology can be used in a power plant. Now, most coal and thermal based power plants generate a lot of hot water which they are simply throwing in the sea. Actually speaking, they should discharge water only 5 degrees above ambient, but most of the power plants end up discharging hot water 10 degrees above ambient. Okay, so what happens is that this is actually polluting the sea environmentally, and therefore the 10 degrees delta T, if you have, it is basically you can use the same technology to make water, and that we have demonstrated here in the North Chennai thermal power station. That's what the picture is shown over here. So these are the challenges. You see, this was a 1 meter pipe that we used for the offshore project, and this was also having a lot of challenges in the towing, and there's a huge learning. We all have actually done these projects ourselves, and the pleasure and the joy that we got out of when the fresh water is generated. You can see my team here totally jubilant. We really enjoyed doing these projects. We learned so much. So just briefly, I'll take a small digression. I'm sure there are a lot of women in this group, and this is addressed at them. Seeing all the offshore work, seeing all the difficult engineering work, there's a tendency to think that, oh, how can a woman do it? This preconceived notion has to change. And basically, as a woman scientist and engineer, we do face a lot of challenges. There are practical difficulties at sites when you're standing alone in the sun for so long. You need a lot of family support and acceptance, which I'm sure is coming as more and more women take up engineering. But you do have to work very, very hard on all fronts, because you have to excel everywhere, and you have a lot of responsibilities at home as well. But that should not deter you, And let me tell you that when I was young, a student like all of you, I was the only girl in the civil engineering class of 60 students. In this world and age of WhatsApp today, they have found me and I'm back on their WhatsApp group now. And I was really pampered, and they looked after me so well whenever we went out for site activities, because civil is a very site oriented discipline. uh, I was really looked after very well, and I had no issues. I went to graduate school at Duke University in USA. Most female students of civil engineering would opt for environmental engineering, and there were very few in structural engineering. And I was probably the only person at that time during my year doing PhD in structural engineering. All the others were master students. So what I want to say is, field and site work are part of the job of a good engineer. Translating drawings to the field and then making it happen is what we should take our joy in. Don't hesitate to go to field and site. The right hand side picture shows me in one of the NIOT vessels. In fact, I used to lead the deployments of the pipe, and I used to myself take charge and tell the deployment contractors what to do. So this can be done. You have to keep courage, and everybody will take you seriously. Being taken seriously is a very important thing, and you can see here, my team really is very cooperative. I get a lot of work done from them, and I believe in leading from the front, and I go with them to the site as well. So this was an aside, but let me tell you, this is important, especially for the women students and the women engineers who tend to drop off after seeing that it requires a lot of hard work, yes, but the rewards and the wonderful feeling of achievement that you get are beyond description or words. So please take this as an example, and all of you, please try to take up hard work and show how engineering can be solving a lot of countries' problems. Now, having diverged a little bit, let me come back to ocean energy. So, in NIOT, we work on three forms. One is wave energy, the ocean current energy, and the ocean thermal energy. Okay, so the wave energy is still very, very difficult, and it is in a nascent stage in India today. But our group has done a lot of work. Right now, we have developed a product for ports. These are called navigational buoys. In every port, to mark, see, in the road you have these markers which cars can see. In the open sea, the ships need some kind of markers to tell them which way to go. So along the channel, you have these buoys, and most of these buoys actually are imported today, and they run using solar panels which get vandalized. So we have developed a wave-powered navigational buoy which runs on wave energy. This has been continuously working at one of the ports here in Chennai, and we have now transferred the technology to industry. The other thing we have developed is the current turbine. There are currents in the ocean, and this can be used to generate power. And this is a small thing, the off-grid one that we demonstrated in Andaman. Now, Andaman is very interested because, in places like Andaman, you have a lot of small islands which are secure, which need to be, like really looked at by security. And many of the times these security are drinking and they have no water to drink, and they're sitting in darkness. So they have requested us for several of these off-grid current turbines, which hopefully when we start putting them for them, it will solve their problem of the remote locations. Now let me come to a slightly different aspect of all this thing that we have talked about. See, every desalination project requires energy. That's the main thing in every desalination, which is why many people are sort of not happy with desalination, because it's so energy guzzling. You need intake structures, you need the outfall structures, you will get the fresh water, the membranes or the thermal components. All that is part of common for all desalination projects, but all of them need energy. Okay, so earlier I told you we need to really seriously think about how to make renewable energy. And now the thought is, so much energy is being used by a desalination plant, means should we use renewable energy to power it? That way it will be clean, green, and it will also be less energy guzzling, right? So we had the wave energy project at Kerala long time ago, and what we did is we used the wave energy to run a reverse osmosis plant in those days in 2003. Okay, this plant was run using the power generated from the wave energy plant, and this was the first ever plant that was drawing seawater from the sea, making fresh water out of it with the energy from the sea itself. We got a lot of interesting reviews for our paper on this, and this was one of the nice achievements where we hybridized wave energy and the desalination. After a successful demonstration, this was decommissioned. So this is that pictures of that project. Then we've also done solar desalination, where the solar energy through solar thermal is used to run an MED, or a multi-effect distillation system, where this is actually making the steam to make the multi-effect distillation happen. Somebody was asking me about some of the types of desalination just now. MED is multi-effect distillation. MSF is multi-stage flashing. Okay. MVC is mechanical vapor compression. TVC is thermo vapor compression. Now, these are all dependent on steam. Okay. Now, the NIOT technology that I showed you does not need steam at all. That is the beauty of it. You just use the temperature that is gradient that is available in the ocean. So this MED system, it needs steam, and therefore the solar thermal was used to create the steam, and then the seawater was desalinated. This was a jointly developed project between the Department of Science and Technology, NIOT, and a company. And this was commissioned successfully in the southern region of India. But now the next challenging thing that NIOT has undertaken is a self-powered desalination. The third type of energy, which I didn't explain to you, and I'm coming to it now. See, I have been telling you repeatedly, there is a thermal gradient in the ocean. This thermal gradient, if you use 20 degrees Celsius, can also make energy, and this is called OTEC, or Ocean Thermal Energy Conversion. Now in NIOT, we have made a laboratory which it's small, because we have to get seawater in tankers here. So it's not a very large laboratory, but it is able to do all combinations. It can run only desalination cycles, it can run only the OTEC cycle, it can run the hybridized cycle. Everything is indigenized. We have made the turbines ourselves, and we have tested it. It's working very well now. So with this learning, I have now taken up the new challenge with my team, and that is the OTEC powered desalination. So we are going back to Kavaratti. Here, what we'll do is, as you know, I told you all desalination plants need energy. In islands like Kavaratti, the diesel generators are used to provide the power. Okay, so this is really bad, because diesel has to come from the mainland, and also diesel is so polluting. So what we have taken up now is that we make power from the temperature gradient, and we also power the desalination plant. So that means this plant will not need any power from the grid. Now you see what a beautiful technological challenge this is. This will have so many challenges. The rest of the desalination plant is what we have done before, but this will have the longest cold water pipe ever made. This is going to be about 4 kilometers in length, and it will go to a depth of about 1 kilometer. Okay, the end of the pipe will be at 1 kilometer, and this will be having the first ever indigenously designed and fabricated OTEC turbine. So again, everything will be indigenous, and this will be the first plant in the world, once it succeeds, to be able to do the OTEC powering the desalination. So this, I think, is a real challenge for engineers, and this should excite young minds, because you are making power out of just a temperature difference in the vast ocean, and you're also making water at the same time. Now behind it, now my talk will draw to a close shortly. So before that, I will just tell you, see, behind all this, these pictures look very beautiful, I mean, they're all at the site, and they look very beautiful, but lot of thing goes behind the analysis, the design, the actual implementations. There's a whole lot of work that has to be done, and some of them, if you are anyone who has taken fluid mechanics, will know there's something called computational fluid dynamics, which you learn when you go to masters. Incidentally, I should tell you that I coordinate a MTech program here in IIT Madras for ocean engineering. We fund 10 GATE candidates each year, and by NIOT. And what we do is that we give them a sort of a hands-on training here. The difference between our program and the normal ocean engineering program is that we actually give a hands-on training here. We also give them shipboard training. We take them on our ships, and then the project, the MTech project, is done with an NIOT problem. Okay, so we offload some of the little problems to the students, and then they get a good project. Many of them do excellent work, and we also get papers out of those. So this is one such complex challenge that we do, the computational fluid dynamics of turbines. Then we do hydrodynamics. See, the vessels and everything that I showed you, all these are floating in the sea. They're all small vessels, a navigational buoy, for instance. These have to be analyzed for the responses in the sea, and they have to be designed. So there's a lot of simulations that need to be done. These are all non-linear and very complex. We have to look at the motion studies, mooring and stress analysis. We also do model studies. See the models on the left-hand side. We test them in the wave basins in IIT Madras or in Anna University, and all these are actually basically a lot of understanding of the responses comes out with these model studies and the analysis. And finally, a lot of work on mooring analysis has to be done as well. So these are all again non-linear, and we do time domain and frequency domain analysis. And so all this goes behind what looks like a project in the end. Starts with all these things, goes on, and then we kind of put them all together, and then finally when it's commissioned successfully, it is totally a very good experience. We also do the P&ID, or the piping and instrumentation. Several instrumentation are required to measure flows, temperatures, pressures, and various other things. We use very sophisticated instrumentation, field mounted instruments, and we have paperless recorders. Basically, I'm trying to show you all these things is the beauty of engineering. Every type of engineering is required in such multidisciplinary fields, and it is really a challenge to use and work and make it all happen together. See, it's not enough if only the civil fellow does his job and goes, or the mechanical guy comes in, and then the instrumentation guy comes with his instruments. The instruments have to work and ensure that the mechanical engineer's numbers and what the instruments are measuring are the same. If there's a discrepancy, is it due to the instrument or is it due to the process calculation? So there's a whole lot of interdependency, and these multidisciplinary fields are really very, very challenging to work on. And lastly, for all of you here today, I would like to tell you the 5 I's, which are identify, innovate, indigenize, industry, and implement. One is identify. First of all, identify what is the need. Like I told you, we have to look at what energy is and what desalination is, where is the water stress, why and how, what is the location, how do we make it happen. So we identify what the need first. Then we really need to sit down and innovate. Let us not do something because it is done elsewhere. Let us do something even if it is not done elsewhere. We are intelligent enough in India to do our own things. We don't need to depend on others. We have to necessarily try to indigenize. Just importing things and putting it together has no value. We need to indigenize. We need to involve the industry. That is why I encourage many of you youngsters to get into the startup mode, make small startups, join hands with R&D and academia to make products. Therefore, industry is very important. Finally, let us all together implement it. And then, as engineers, let us strive towards clean water and green energy. So I hope I've motivated many of you to continue with engineering or take up engineering or get into academia and research and technology development. Okay, so there are a couple of questions. One of them was, which is the cheapest? Why I'm just picking up one question is, this is a question which everybody asks. And let me tell you, you can't talk about desalination just like that as a number. You have to talk about it in terms of the power requirement. Normally, we go by how many units are used per cubic meter of water, or rather 1,000 liters of water. As of today, RO is the cheapest. It consumes the least power, but it also has got the most side effects or environmental impacts compared to thermal systems. And multi-stage flash is the one which uses the highest amount of energy. We at LTTD, because we have just done a few plants now, we are in the middle somewhere. We are trying to go towards as low an energy as possible, and that is why we use renewable energy we are trying hard to use renewable energy. Once again, thank you for listening, and I hope you have learned something, and I hope I have motivated you to, uh, you know, remain engineers, continue as engineers, learn more, get into research, get into technology development. Thank you very much.